Okay, chapter 4, this is exercise 55. What we have is two typists at the agency. The first typist makes an average of 3 errors per page or per article, and the second one 4.2 per article. So we don't know which typist we're going to get. In fact, it's a 50-50 chance. And we want to approximate the probability, not the expected number of errors, but what we're actually looking for is the probability that our paper will have no errors. So again, we can assume that this is approximately Poisson because it's a small probability, a large number, and when I say large number, I mean of all the possible words or letters in the article, the typos are only going to be a small percentage of those. So every particular word or any given word has a very low probability of having a typo. So the issue is we have two different distributions, so we'd actually split it up into the probability that x equals 0, if x is the number of errors, probability that x equals 0 given that we get typist 1, times the let me write this out just instead of saying it all. Okay, here we go. Despite the chicken scratch style here, I think this may be more helpful. So the probability that we're going to get 0 errors here is the probability that we're going to get 0 errors given that we have typist 1 times the probability we have typist 1 plus the probability that we get 0 errors given that we have typist 2 times the probability of getting typist 2. So notice this is going back to what we had looked at in the previous chapter where we have this total probability of x equals 0, and we're going to split it into all the possible cases. So notice that either we are going to have typist 1 or we're going to have typist 2. Those are the only way that we're going to get that 0 errors. In fact, those are the only two possibilities of doing anything in this problem. We're guaranteed to have one of these, and we do have to take into account the probability that we're going to have either case. In this case, they're going to be the same, but in some cases they wouldn't. Okay, then we just replace the probability of getting either typist is 0.5. Probability of getting 0 errors with typist number 1. Again, this is a Poisson distribution, so we just plug 0 in for k on the PMF. And the lambda there for typist 1 is 3. We're given that in the problem. Same thing here, 0 in for k and the PMF of the Poisson, except here it would be 4.2 for the lambda. Okay, and let's see. So this is not the one we were working with. Okay, right here. So this would then give us, boil down to this final solution when we solve that equation. Okay, on 63, okay, 63, there are several ways we could approach this, and you may recognize it as a Poisson, but not be quite sure how to set it up or what the lambda is, because if you put lambda is 0.5, because every minute 0.5 person comes in, then how do you deal with the fact that there's a 5-minute period here? Or if you put Poisson as 2, the number of minutes that it takes for a specific person to come in, again, how are you handling the 5-minute frame? Those are possibilities. What I like to do is choose my units carefully. So in this case, I would look the number of people that come in every 5 minutes. That way, once I get to the actual question, it'll just fit right in there. So I do have to adjust, though, the rate. So what would be the average number? What would be the expected value of people coming in 5 minutes? Well, if there's 1 every 2 minutes, I can set up a proportion 1 over 2 equals x over 5, solve for x to be 2.5. So if I'm looking at the distribution of people coming in every 5 minutes, on average that would be 2.5. Once I do that, the probability that no one enters is simply putting 0 in for k in the PMF of the Poisson, and that would give me this here. And then on the second part, the probability that at least 4 people, there's really no easy way to get around subtracting out the chance for 0, 1, 2, and 3 people. And then that would give us the probability that there would be 4 all the way out to infinity number of people that would come in during those 5 minutes. So we're just subtracting that from 1.